The lack of curiosity about Neptune is one of the scariest things about new generations of kids. Neptune, the distant icy giant at the edge of our solar system, has been shrouded in mystery for decades. An immense dark vortex within its atmosphere is often described as a giant storm, but such words don't fully convey its magnitude. We're talking about a storm the size of planet Earth or larger. From bizarre atmospheric phenomena to unexplained anomalies in its magnetic field, there's more to Neptune than meets the eye. With winds reaching up to 1,500 miles per hour, the fastest in our solar system, buckle up because what you're about to discover will change everything you thought you knew about Neptune. If Neptune's influence appears every 3,600 years, wouldn't there be some sort of documentation from 3,600 years ago, at the very least? In August of 1977, Voyager 2 embarked on an extraordinary journey through our solar system, venturing where no spacecraft had gone before. It set out to explore the outer reaches of our celestial neighborhood, marking a remarkable moment in space exploration. After a 12-year journey, Voyager 2 reached Neptune in 1989. As it approached the distant ice giant, it captured breathtaking footage that unveiled a majestic world shrouded in stirring bands of azure clouds. Imagine witnessing this distant sibling of Jupiter adorned in shades of mesmerizing blue. Among Neptune's mysterious features, Voyager 2 detected a colossal storm raging across its atmosphere, resembling a massive slate-colored uproar. Additionally, the spacecraft discovered four mysterious rings encircling the planet along with 6 previously unknown moons, adding to the allure of this distant realm. Despite its epic voyage spanning 7.1 billion kilometers, Voyager 2's encounter with Neptune was fleeting, lasting only a few hours. However, this brief rendezvous provided humanity with unprecedented views of the distant ice giant, capturing the essence of Neptune's captivating beauty. When considering Neptune, many of us recall the iconic image memorialized by Voyager 2, a portrait showcasing the planet's towering white clouds and turbulent storms, all bathed in a famous yet mistaken hue of blue. In reality, Neptune's true color is a softer, lighter shade of greenish blue, a subtle detail often overlooked in the grandeur of space exploration. When venturing online in search of more snapshots of Neptune, people quickly notice a scarcity of images. Despite Voyager 2's impressive feat of flying within a hair's breadth of just 4,950 kilometers from Neptune's surface, the number of available photos remains surprisingly low. But why is Neptune so elusive to capture on camera? Imagine, Neptune resides a staggering 30 times farther from the Sun than Earth, meaning it receives only a fraction of the sunlight that our planet enjoys. Consequently, when Voyager 2 finally caught up with Neptune after its gravity-assisted journey past other outer planets, it was hurtling through space at an astonishing speed of 27 kilometers per second. While Neptune may seem like a distant speck in the universe, its allure lies in its perplexing blue hue and mysterious atmosphere. However, capturing these mesmerizing details proved to be quite the challenge for Voyager 2. With Neptune receiving only a mere 0.1% of the sunlight that reaches Earth, the spacecraft struggled to snap clear, non-blurry photos amidst the dimly lit expanse. Yet, Voyager 2's ingenuity knew no bounds. By deftly working its thrusters to swing as it soared past and employing extended exposure techniques, the spacecraft managed to capture and transmit back to Earth some of the closest and most mesmerizing images ever taken of Neptune. Just a couple of hours before Voyager 2 zoomed past Neptune, it captured an incredibly detailed picture. In it, scientists got a close-up view of some interesting features high up in the planet's atmosphere, long, wispy clouds that resemble the cirrus clouds seen on Earth. These clouds, however, are not made of water vapor like Earth's clouds, they are crafted from frozen methane, giving them a surreal appearance. Imagine these cloud formations stretching for thousands of kilometers, running parallel to Neptune's equator. They are not just puny clouds either, each streak measures between 50 to 200 kilometers wide. These clouds are so high up that they cast shadows onto the hazy layer about 50 kilometers below. What's even more mind-blowing is that even though Voyager 2 had already checked out all the other gas giants before Neptune, it wasn't until Neptune that humanity got its first ever glimpse of these elusive cloud shadows. As evidenced by the grainy image captured, these high-altitude clouds are like fleeting guests in Neptune's atmosphere, always on the move and changing shape. Recent observations from the Hubble Space Telescope revealed that these clouds can form and disappear in the blink of an eye, showcasing the dynamic nature of Neptune's weather patterns. When this picture was captured, strong winds would have been swirling around the ice giant, some blowing as fast as 2,100 kilometers per hour. That's 3 times quicker than winds on Jupiter and almost 9 times speedier than those on Earth. Voyager 2 revealed that Neptune experiences some of the most extreme weather in the solar system, and when the spacecraft flew by, it encountered a striking example of this phenomenon. This image is the closest view ever captured of the once furious storm known as the Great Dark Spot, a large oval-shaped cyclone resembling Jupiter's Great Red Spot. This immense weather system was roughly the size of the entire Earth. What's fascinating about this image is that the center of the storm appears to be relatively clear of clouds, forming a vast dark void slicing through Neptune's atmosphere. Neptune is an incredible ice giant about 4 times wider than Earth. Its radius is around 15,300 miles, and it has an enormous volume of 15 trillion cubic miles. To put that in perspective, Neptune is 58 times larger in volume than Earth. This fascinating planet is mostly made of water, methane, and ammonia. Unlike Earth, Neptune doesn't have a solid surface. Instead, its thick atmosphere extends deep into the planet, reaching down to a mantle made of methane and ammonia ice surrounding a rocky core. Interestingly, scientists think that Neptune might even have a superhot ocean hidden deep inside. Despite its icy name and outer appearance, the conditions inside Neptune are anything but cold. But how can a planet sustain such an ocean when it is so far from the Sun? Sunlight takes a whopping 4 hours to reach Neptune's massive surface. Neptune is incredibly cold, with an average atmospheric temperature of -360 degrees Fahrenheit, making it one of the chilliest places in the solar system. Interestingly, most of Neptune cooled down between 2003 and 2018, though there was some warming near the South Pole from 2018 to 2020, likely due to seasonal changes in the atmosphere's chemistry. The mystery of how an ocean might form inside this icy giant remains unsolved. However, scientists have some theories. One idea is that internal heating caused by gravitational compression or interactions between Neptune and its largest moon, Triton, might play a role. Yet not all researchers agree. For instance, scientists Sloan Viktorovich and Andrew Ingersoll argue that the chances of oceans forming on Neptune due to its internal heat are quite slim, estimating it at only 15%. Their calculations suggest that it might take 1 billion years for the probability of such an ocean to rise to 40%, assuming the giant continues to cool down over time. One interesting theory for Neptune's immense internal energy is that it might have collided with a cosmic object long ago. Neptune stands out as the only planet that radiates nearly 3 times more energy than it absorbs from the Sun. This unusual energy output might be linked to the planet's significant 28 degrees tilt on its axis, which is quite similar to Earth's tilt. This tilt means Neptune experiences seasons much like Earth does, but with a twist: each season on Neptune lasts around 40 years. To put it in perspective, 1 Neptune year equals 165 Earth years, but a day on Neptune is just 16 hours long. This fast rotation generates extremely strong winds. Neptune's atmosphere is composed mostly of hydrogen, making up 80%, with helium accounting for 19%, and a small fraction, about 1%, of other gases, including methane. The striking blue color of Neptune is a result of methane clouds in the upper atmosphere, which absorb red light and reflect blue. Methane plays a significant role in shaping the atmospheres of both Neptune and Uranus. Despite being the farthest planets from the Sun in our solar system, these ice giants still receive a significant amount of solar radiation, albeit much less intense than what inner planets like Earth receive. Neptune's vivid blue coloration has captivated astronomers for centuries, but the exact mechanisms behind its striking color continue to intrigue scientists. One fascinating aspect is the presence of high-altitude clouds composed primarily of methane ice crystals. These clouds scatter sunlight in a way that enhances the blue coloration, similar to how Earth's atmosphere scatters sunlight to create blue skies. Furthermore, Neptune's dynamic atmosphere exhibits a multitude of features, including massive storms and powerful winds. On the other hand, Uranus presents a different aesthetic with its muted pale blue color. This planet's unique tilt, where its axis is nearly parallel to its orbital plane, results in extreme seasonal variations. During its long polar winters, Uranus experiences prolonged periods of darkness, hindering the formation of high-altitude methane clouds that contribute to its overall coloration. In addition to methane, both planets' atmospheres contain trace amounts of other gases, including hydrogen, helium, and ammonia. These gases, along with the intricate interplay of temperature, pressure, and atmospheric dynamics, create a complex and dynamic environment worthy of scientific exploration. Neptune holds many mysteries within its icy depths. Its intense blue coloration, derived from methane in its atmosphere, adds to its allure. But beyond its captivating hue lies a world of extremes. The storms that rage across Neptune's surface are not just any storms, they are colossal tempests, some spanning thousands of kilometers. These atmospheric disturbances, marked by dark and white patches, are the result of Neptune's rapid rotation, completing a day in just under 16 hours. This rapid spin generates intense wind currents, making Neptune the windiest planet in our solar system. The infamous Big Dark Spot, discovered by the Voyager 2 spacecraft, was a monumental find. This swirling vortex, resembling a gigantic cyclone, churned at breakneck speeds faster than any storm on Earth. Its disappearance, observed by the Hubble Space Telescope, revealed the transient nature of Neptune's weather systems. Moreover, Neptune's magnetosphere, a region of space influenced by its magnetic field, is strikingly tilted compared to the planet's rotational axis. This unusual alignment creates complex interactions with the solar wind, resulting in auroras that dance across the planet's atmosphere. In 2018, Hubble captured the formation of a new storm on Neptune, reminiscent of a similar event detected nearly 3 decades earlier in 1989. These swirling storms, lurking deep within the planet's atmosphere, remain mysterious to researchers despite years of study. What makes these storms particularly captivating is their gradual evolution over time. Unlike the fleeting storms we witness on Earth, these atmospheric giants take years to develop, suggesting a complex and long-term process at work beneath Neptune's turbulent skies. But the plot thickens as the new 2018 storm embarks on an unexpected journey. Initially drifting southward, it seemed destined to fade away into obscurity. Yet, much to the surprise of scientists, it abruptly reversed course and began its northward trek, defying conventional expectations of planetary weather patterns. Adding to the interest, a smaller vortex appeared to break away from the main storm. NASA researchers believe that this miniature whirlwind may play a pivotal role in the fragmentation of the larger storm, a phenomenon never witnessed before in Neptune's atmosphere. What's more, the presence of bright methane clouds, known as scooter clouds, within these storms adds another layer of complexity. These swiftly moving clouds, propelled by forces still not fully understood, hint at intricate atmospheric dynamics occurring deep within Neptune's gaseous envelope. Neptune, like its gas giant counterparts, boasts a fascinating feature, a system of rings. These rings were captured in stunning detail by the James Webb Space Telescope in 2022, revealing a spectacle unseen for over 3 decades since Voyager 2's last snapshot. The image unveiled not just Neptune's rings, but also its accompanying satellites, painting a portrait of icy grandeur in the vastness of space. Within this cosmic jewelry box, 5 distinct rings orbit Neptune, each bearing the name of a prominent astronomer whose contributions shaped our understanding of the distant planet. The closest and most diffuse ring, known as Gal, spans a staggering 26,000 miles with a radial width of 1,240 miles. Composed predominantly of dust particles, it shimmers faintly, embodying the ethereal beauty of the celestial realm. Next in line is Leveria, radiating a brighter glow but marred by a slight inconsistency in its measurements. Spanning a width of just over 62 miles, the Larsell ring, however, steals the show with its expansive width of 2,485 miles, dwarfing its counterparts. Despite its grandeur, its dust content is relatively scant, hovering between 20 to 40%, lending it a pristine allure. Arago, the 4th ring, is a challenge to spot. Tucked away on the fringes of the Larsell ring, its diminutive radius of 35,540 miles renders it nearly imperceptible. Lastly, Adams, the narrowest of the rings, orbits at a distance of approximately 39,724 miles, boasting a mere width of 35 kilometers. What truly makes this ring system fascinating are its arcs. These arcs are mysterious bright bands of dust circling the edge of the ring, creating a mesmerizing display. Each of these arcs has been given a unique name: freedom, brotherhood, courage, and equality. These names reflect the interesting nature of their existence. Interestingly, these arcs are not static, they are dynamic. Brotherhood and equality, in particular, are constantly exchanging material and changing in size, making them even more captivating to scientists. The reason behind the formation of these arcs remains a mystery. However, researcher Matthew Tiscoreno suggests that they might have formed due to the collapse of a parent companion or another object within the Roche limit, which is the distance within which a celestial body, due to tidal forces, will disintegrate due to a second body's gravitational forces exceeding its own. Adding to the intrigue of Neptune's ring system, the James Webb Space Telescope also captured images of 7 out of Neptune's 14 moons. Neptune's moons are categorized into regular and irregular groups. The Webb telescope managed to photograph 6 of the regular inner moons. Some of these moons, like Despina and Galatea, play crucial roles in maintaining Neptune's rings by acting as shepherds, guiding and shaping the dust around them. Despina and Galatea, in particular, have fascinating orbits that influence the structure of the rings. Their gravitational forces help to contain the ring particles, preventing them from spreading out and maintaining the sharp edges of the rings. These moons' shepherding role is crucial in sustaining the narrow, well-defined appearance of Neptune's rings. In addition to Despina and Galatea, the Webb telescope also observed Triton, Neptune's largest moon, which is unique because it orbits the planet in a direction opposite to Neptune's rotation. Triton is believed to be a captured Kuiper belt object, making it an object of immense scientific interest. It has geysers that spew nitrogen gas, creating a thin atmosphere and suggesting active geological processes. One of the most captivating elements in Webb's picture is the appearance of Triton, a distant bright satellite. Triton shines like a star in the image because it emits much more light than its host planet, Neptune. This luminosity is due to Triton being almost entirely cloaked in nitrogen ice, which reflects around 70% of the sunlight it receives. Triton holds the title of Neptune's largest moon, outstripping even Pluto in size. Its diameter spans a whopping 1,680 miles, accounting for a staggering 99.7% of all the mass possessed by Neptune's moons combined. What sets Triton apart further is its frigid demeanor. It ranks as the chilliest geologically active entity across the solar system, with surface temperatures plunging to a bone-chilling -391 degrees Fahrenheit. This icy terrain, acting as a mirror to sunlight, contributes to its glacial condition similar to other icy moons. Around ice giants, Triton experiences tidal locking, which means only one face perpetually faces its host planet. In essence, Triton emerges as a celestial marvel, not just for its size and icy allure, but also for its geological activity and cosmic chill, making it an enigmatic world worthy of exploration and admiration. Triton is quite the maverick in our solar system. Unlike most satellites, it marches to the beat of its own drum with a retrograde orbit, meaning it travels in the opposite direction compared to its parent planet, Neptune. Imagine, while other moons obediently circle their planets in one direction, Triton rebels and takes the scenic route. But why does Triton defy the norm? It's believed Triton wasn't originally from around here. Scientists think it hails from the Kuiper belt, a distant region filled with icy remnants from the early days of our solar system. At some point, Neptune, being the cosmic magnet it is, snagged Triton into its gravitational embrace. As Triton hitched a ride with Neptune, it hit the brakes, slowing down to avoid a head-on collision. This unconventional dance led Triton to settle into its peculiar orbit, where its poles and equator take turns facing the sun. Imagine a cosmic game of hide-and-seek with sunlight. But Triton's rebellious spirit comes with consequences. Its journey could spell trouble for Neptune's other satellites, as Triton's trajectory might lead to cosmic collisions. Unlike Jupiter, with its bustling entourage of moons, Neptune has just a handful of companions. Triton's arrival shook things up, highlighting the stark contrast between the two gas giants. Around Neptune, there's an eerie dance of moons, but Triton stands out among them. It's not just any moon, it's a captured wanderer from the Kuiper Belt, a vast region beyond Neptune populated with icy objects. Imagine Triton as a cosmic nomad lured into Neptune's orbit by its immense gravitational pull. When Voyager 2 swung by in 1989, it captured snapshots of Triton's surface, revealing a landscape like no other. The images unveiled a patchwork of frozen plains, towering cliffs, and mysterious dark streaks. But what caught scientists' attention were the towering plumes erupting from its surface, hinting at unseen forces at play. Analyzing the craters dotting Triton's terrain, scientists uncovered clues about its tumultuous past. Some craters appeared remarkably fresh, suggesting recent impacts, while others showed signs of erosion, hinting at a dynamic surface reshaped by icy geysers and cryovolcanism. But the most tantalizing discovery was yet to come. Beneath Triton's icy facade, scientists suspect a hidden, possibly liquid, ocean, kept warm by tidal heating generated by Neptune's gravitational tugs and Triton's own eccentric orbit. If true, this subsurface ocean could harbor alien life, making Triton a prime target for future exploration. Then there are the plumes, towering jets of icy material spewing into space. These geysers not only hint at Triton's active geology but also suggest a subsurface reservoir of volatile compounds waiting to burst forth. Despite its frigid temperatures, Triton is a world of intriguing complexities. Deep beneath its icy surface, there exists a hidden reservoir of ammonia, a compound often associated with cleaning products on Earth but vital for the peculiar dynamics of Triton's subsurface ocean. This ammonia acts as a sort of antifreeze, slowing down the freezing process of water and potentially creating conditions hospitable for life, albeit in a realm vastly different from our own. The interplay of sunlight on Triton's surface further complicates its icy facade. When the distant rays of the sun penetrate its thin atmosphere, they trigger a delicate dance of molecular compression. Nitrogen, the dominant component of Triton's atmosphere, undergoes a curious transformation, becoming pressurized beneath the icy crust. Eventually, this built-up pressure is released in magnificent plumes that erupt into the vacuum of space, a spectacle unseen on any other moon in our solar system. Despite these captivating phenomena, deciphering Triton's true nature remains a tantalizing challenge. Its potential as an oceanic world harboring hidden seas beneath its icy shell sparks the imaginations of scientists and space enthusiasts alike. However, confirming this hypothesis requires further exploration and observation, tasks made all the more daunting by Triton's remote location and the technical challenges of space exploration. Moreover, Triton's thin nitrogen atmosphere, a product of solar heating, adds another layer to its mysterious character. This fragile veil of gas hints at the intricate interplay between Triton's surface and the distant sun, shaping its atmospheric dynamics in ways yet to be fully understood. Exploring the mysteries of Triton's origins unveils a captivating narrative of cosmic migration and gravitational ballet. Triton stands out not only for its size but also for its peculiar backward orbit, contrary to the forward motion typical of moons in our solar system. This unusual trajectory hints at Triton's tumultuous past as a wanderer from the frigid realms of the Kuiper Belt. Within the Kuiper Belt's icy expanse lies a treasure trove of celestial wonders. Among them are not only dwarf planets like Pluto but also enigmatic objects known as trans-Neptunian objects. These icy bodies, ranging from a few kilometers to hundreds of kilometers in diameter, hold clues to the solar system's early formation and evolution. One of the most remarkable features of the Kuiper Belt is its resonance with Neptune. Resonance occurs when the gravitational interactions between Neptune and objects in the belt cause them to orbit in a synchronized dance. Pluto, for instance, completes 2 orbits around the Sun for every 3 orbits Neptune makes. This harmonious relationship suggests a delicate balance of gravitational forces that has persisted over billions of years. Furthermore, the Kuiper Belt's composition provides insight into the primordial conditions of the solar system. Rich in volatile compounds like methane, ammonia, and water ice, these icy bodies are relics of the solar system's infancy, preserving a frozen record of its ancient past. Piecing together these celestial puzzles, scientists speculate about Neptune's journey through the universe. The concept of planetary migration proposes that Neptune, along with its distant siblings Uranus and the gas giants Jupiter and Saturn, may have undergone significant movements during the solar system's formative years. Such migrations could have been triggered by gravitational interactions with other planets or passing stars, reshaping the architecture of our cosmic neighborhood over vast periods. As the ice giant made its migratory journey, it played a crucial role in retaining numerous celestial objects within the Kuiper belt. Without this migration, the gravitational forces at play could have flung many of these objects out of the solar system, potentially altering the dynamics of our cosmic neighborhood. Interestingly, this migration might have also influenced the orbits of other planets, including Neptune itself, hinting at the intricate dance of celestial bodies in our solar system. Neptune continues to bewilder astronomers with its mysteries. Beneath its serene surface lies a world shrouded in secrecy, with questions lingering about its inner composition and the mechanisms behind the formation of ice giants like it. Scientists are eager to delve deeper into Neptune's depths to unlock the secrets hidden within its icy core, hoping to uncover clues about the origins and evolution of these distant worlds. Future scientific expeditions hold the promise of unraveling the intricate chemistry and dynamics of ice giants, shedding light on their role in the grand variety of the universe. These missions will not only deepen our understanding of Neptune but also provide invaluable insights into the broader processes shaping planetary systems, both within and beyond our own. With each discovery, humanity edges closer to unraveling the cosmic mysteries that have captivated us for generations, arousing curiosity and expanding the boundaries of human knowledge. Every innovation in modern technology opens another chapter in the story of our space exploration adventures. Looking back, we have no doubt made giant strides forward in our space missions since Neil Armstrong set foot on the Moon. Still, the vast cosmos and our inability to fully unravel all the mysteries of the universe is a constant reminder that there is so much we need to learn. This is where NASA's innovative projects and instruments come in. The James Webb Space Telescope, JWST, was launched to unveil distant worlds and peep into the origins of the universe. Most importantly, this equipment is a monumental extension of NASA's previous missions. The excitement of understanding cosmic mysteries of the past is an epic adventure we are still curious about. We remain fascinated by the Big Bang, the formation of our solar system, and, more importantly, the possibility of alien life outside our home planet, Earth. Could our knowledge of the solar system evolve into a new field of study? Will the new information gathered through the James Webb Telescope force us to reconsider our fundamental views of the universe? These questions prompt a review of our current knowledge, especially our understanding and classification of Pluto as a dwarf planet. Thanks to the New Horizons mission and its groundbreaking discoveries, we've been able to learn more about Pluto. The billion-dollar investment has revolutionized NASA's efforts and expanded our understanding of the icy planet. Before the New Horizons mission, our knowledge of Pluto's surface was minimal. The most detailed image we had, taken by the Hubble Space Telescope in 2002, revealed a mysterious mix of colors on Pluto's surface, including shades of orange, white, and black, along with a bright spot that caught scientists' attention. Given the few details offered by the Hubble Space Telescope, investigating Pluto was akin to trying to solve a puzzle with only a few jumbled pieces. Then, the James Webb Space Telescope appeared on the scene. It journeyed into Pluto's orbit, taking several stunning pictures that gave scientists a whole new understanding of that planet. The telescope captured a glimpse of Pluto's surface, including the craters, the plains, and the mountain peaks. All of the planet's features were present in the finest details, showing traces of its geological history. The scene was like being granted a VIP backstage pass to a magic show and finally being able to see all the amazing things that had been hidden from us. These pictures not only fascinated scientists but also captured the imagination of many people around the globe. It ignited a new wave of curiosity and passion for the unknown regions beyond our planetary neighborhood. In July 2015, the New Horizons mission accomplished its primary goal. The spacecraft flew past Pluto and its many moons and sent back the first detailed pictures of this celestial body to Earth. This moment in history has turned out to be an important step forward in space exploration. Astronomers obtained data about Pluto and its moons that they previously didn't have. The success of the New Horizons mission opened other avenues for NASA to explore the vast expanse of the Kuiper belt. Recognizing the urgent need for a solid understanding of distant celestial bodies, NASA set its sights on planets situated between Neptune's orbit and nearly 50 astronomical units (AU) from the Sun. The single most striking event of the mission was definitely the close flyby with Pluto and its biggest moon, Charon. Additionally, New Horizons captured clear images of Pluto's four other moons, Nix, Hydra, Kerberos, and Styx. The process of data collection took 15 months, and by October 25, 2016, the goal was achieved. The spacecraft successfully collected 6.25 gigabytes of valuable information. But what is the importance of this huge amount of information for NASA's understanding of the dwarf planet? After data collection, the findings from the New Horizons mission were so unique and distinctive that scientists had to create new high-tech data models to interpret the results. In time, it became clear that Pluto was subjected to dramatic surface and atmospheric variations, which contradicted initial expectations. Despite its reclassification as a dwarf planet, Pluto displayed a dynamic nature. It evolved at a rate that prompted NASA to reassess and revise existing knowledge about this intriguing celestial body. NASA's high-definition pictures of Pluto reveal fascinating details about this distant dwarf planet. One striking feature is Pluto's heart-shaped region, aptly named the Heart of Pluto. This geological phenomenon, scientifically termed the Sputnik planum, plays a major role in shaping many of Pluto's surface features. Surprisingly, this heart-shaped region is not warm and beating, but rather cold, icy, and almost frozen. In fact, it's a vast expanse of nitrogen ice spanning over 1 million square miles. The presence of this enormous nitrogen glacier at Pluto's heart has significant implications. It is responsible for a process called true polar wander, which causes the planet's spin axis to shift. Before NASA's mission, scientists were unaware that Pluto's heart-shaped basin sits opposite its largest moon, Charon. This reorientation of Pluto has intriguing consequences, particularly regarding the relationship between Pluto and Charon. In simple terms, the alignment of Pluto's heart-shaped basin with the tidal axis between Pluto and Charon suggests that the heart's presence has an influence on the planet's orientation. This means that the gravitational pull between Pluto and Charon, coupled with the presence of the Sputnik planum, has caused Pluto to tilt slightly on its axis. This newfound understanding sheds light on why Pluto is such a dynamic and intriguing world. Despite being uninhabitable for humans, Pluto's icy surface and the massive nitrogen glacier at its core contribute to its unique characteristics. This includes its tendency to tip due to the imbalance in its mass. Pluto's huge mass, coupled with the gravitational pull of its moons, can trigger a phenomenon known as true polar wander. This phenomenon happens when a planet aligns its axis of rotation with a more favorable orbit. However, the presence of the thick ice sheet alone isn't sufficient to cause such a significant reorientation. While the massive ice glacier contributes to Pluto's mass, it is not the only factor driving the dwarf planet's tilt. The strong tidal forces experienced also play a role. In a remarkable turn of events, recent technological advancements have allowed scientists to delve deeper into Pluto's mysteries, leading to a groundbreaking discovery. Unknown to us, Pluto has a sea hidden beneath its icy skin. This is a revolutionary discovery as it overturns our previous scientific assumptions about the planet's structure and origins. The existence of an ocean as one of Pluto's internal features radically alters our view of this distant moon, placing it among the other oceanic moons in the solar system like Titan, Enceladus, and Europa. Although there is currently no evidence that life could exist in Pluto's ocean, the fact that it may even exist makes us question whether extraterrestrial environments could be habitable. This discovery provides grounds for consideration of life beyond Earth and heightens the stakes for studying and finding oceanic worlds in our solar system. NASA also acknowledges that, despite the absence of conclusive evidence, extraterrestrial life remains a viable hypothesis. Another relevant discovery through NASA's Cassini mission was an ocean rich in phosphorus detected below the icy surface of Enceladus, a satellite orbiting around Saturn. This finding ignited continuous discussions about the possibility of extraterrestrial life, since phosphorus is vital for the formation of DNA and RNA, constituents of the molecular basis of life. Although Enceladus remains a potential astrobiological target for space research, the complexity of assessing the habitability of Pluto takes a different turn. Pluto's case is different because, while the imaging equipment is advanced enough to take clear pictures of its surface, they are not equipped to probe into its habitability. This failure to determine the exact chemical composition of Pluto's subsurface water makes it impossible to expand our knowledge and conclusively determine if Pluto can host life. NASA continues to invest in exploring icy worlds like Pluto, but presently the equipment for estimating the nutrients of its oceans is non-existent. However, this doesn't diminish the value of studying Pluto. The planet offers insights into various aspects of planetary science, from understanding its geological features to unraveling its origins and evolution. Each new discovery adds to our knowledge of the solar system and fuels our curiosity about the possibility of life beyond Earth. When we delve into the high-resolution images of Pluto, we uncover a multitude of hidden features, some of which may astonish you. Among these discoveries is a lake nestled within a mountain range just west of Pluto's iconic heart, measuring approximately 20 miles wide, equivalent to about 32 kilometers. This strange body of liquid now appears frozen. However, clues scattered across the dwarf planet's surface hint at its past existence as a flowing lake brimming with a mysterious substance. The existence of a lake on Pluto is even more astonishing because it is located in the extreme cold, with temperatures of up to -230 degrees Celsius or -382 degrees Fahrenheit. Although it is unclear exactly what the liquid was made of, scientists suspect that it might have been liquid nitrogen. It is speculated that billions of years ago, liquid nitrogen may have been responsible for the creation of riverbeds. Riverbeds and complex gullies, such as the beautiful landscape shown in the photograph, illustrate the ability of liquid nitrogen to pool and flow on a world so distant from the warmth of the Sun. This phenomenon is attributed to Pluto's fluctuating surface temperatures and pressures. As the dwarf planet orbits closer to the Sun, its surface undergoes subtle warming, causing nitrogen ice to transition from solid to gas under specific conditions. This transition may also lead to the formation of liquid nitrogen, giving rise to these unexpected features. Pluto further displays another enigma as scientists examine its hazy atmosphere, clearly illustrated in the images received. While Earth's atmosphere differs significantly from Pluto's, the composition of gases enveloping the distant dwarf planet adds to its allure and complexity. It offers scientists invaluable insights into planetary atmospheres and the broader dynamics of celestial bodies in our solar system. Pluto's atmosphere is incredibly thin, about 880,000 times thinner than Earth's atmosphere. It is believed to form when sunlight vaporizes surface ice, leading to a reaction with methane and other molecules. This reaction produces a complex mix of hydrocarbons, resulting in a smog-like haze. These haze particles, which scatter blue light, settle down through the atmosphere, forming intricate horizontal layers that extend to altitudes of over 120 miles or 200 kilometers. With Pluto getting farther from the Sun every 248 years, its atmosphere continues to freeze, inducing a type of snow that falls and sticks to the surface of the planet. However, the specific nature of these snow particles remains a mystery. Scientists are still unable to determine if the snowfalls are grainy or flake-like. There's also a possibility that this snowfall could manifest in the form of blizzard-like winds or a soft snow moving around the dense, cold fog. So far, scientists have observed what appears to be a layer of nitrogen snow that condensed from the atmosphere and settled on the surface in regions like Tombor Regio. This may help scientists identify the kind of snowfall that occurs on Pluto as investigations continue. One of the most striking features on Pluto is its snow-capped mountains in the southern hemisphere, reminiscent of the Alps on Earth when viewed from the International Space Station. However, upon closer inspection, these mountains are markedly different. They are composed of water ice, frozen as hard as granite, and covered in a type of frozen methane snow. Some of these towering peaks can reach heights of up to 2.2 miles or 3.5 kilometers above the surrounding terrain, similar to the Rocky Mountains in North America. While seeing mountains on Pluto isn't shocking, scientists are unable to explain how these mountains are formed. On Earth, mountains are typically the result of tectonic movements or volcanic activities. Meanwhile, the mountains on Pluto show no evidence of tectonic or volcanic activities. As such, scientists propose that Pluto's mountains are formed through a process called sublimation erosion. Sublimation erosion occurs when frozen materials like nitrogen or methane on Pluto's surface are exposed to sunlight and transformed directly into gas, leading to the erosion of the surrounding terrain and leaving behind tall, spiky peaks. Remarkably, Pluto apparently regenerates its surface in some regions. Evidence suggests that a cold, slushy, lava-like substance has flowed over its landscape at various times. This unusual phenomenon is called cryovolcanism, where icy volatiles such as water, methane, and ammonia are erupted instead of lava. The same cryovolcanic activity is also seen on other icy moons like Enceladus and Europa. The presence of mountainous regions with pits or depressions on their surfaces points to the cryovolcanic activity of Pluto. One compelling example is Right Mons, a mountain in Pluto's southern hemisphere rising 2.5 miles or 4 kilometers above its surroundings, with a wide summit depression. This feature, seen in close-up images, is suspected to be an ice volcano, potentially the largest of its kind in the outer solar system. Another intriguing discovery on Pluto's surface is extensive fields of dunes resembling those found in deserts on Earth, stretching across the western edge of its heart-shaped region. These dunes are another mystery that needs to be solved to study extraterrestrial areas where people have not yet set foot. The features on Pluto's surface, including its dunes, are similar to those found on Earth. Dunes on Earth are formed by the movement of wind that carries particles and deposits them in specific areas. However, the dunes on Pluto exhibit unique characteristics. They may have formed not only from wind action but also from the melting of nitrogen ice, causing sand-sized methane ice grains to be lifted by rising gases and then carried away once airborne. Moreover, Pluto's dunes are significantly larger than those on Earth, with some as tall as mountains and stretching for many miles. This is likely due to the lower gravity on Pluto, allowing particles to be transported more easily and creating these impressive features. Another intriguing aspect of Pluto's landscape is the presence of iceberg-like structures scattered across its heart-shaped region. These structures appear to be fragments of ice that have broken away from larger formations. Each fragment measures 1 to several miles wide and seems to float across the frozen surface below. Scientists believe these icebergs consist of frozen water. Since water ice is less dense than nitrogen ice, when they break off and are pushed into Pluto's heart, possibly through glacial flows, they are subject to the motion of the nitrogen ice below, resulting in the peculiar shapes observed in this region. The cell-like formations covering Pluto's heart also reveal information about the planet's geological processes. These formations, resembling a process called convection, occur when a fluid is unevenly warmed, whether by the sun or a boiling kettle. This convection process is believed to be a signature of Pluto's dynamic and ever-evolving surface, shedding light on the complex interplay of forces shaping this distant world. The presence of convection on Pluto suggests that something beneath its heart-shaped region is warmer than the surface. This causes the frozen nitrogen plains to slowly move through the years. By closely examining the images, scientists have noticed that the icebergs tend to gather around these convection cells and are likely being pushed to the edges by the underlying forces. Scientists continue to study these formations and other characteristic features of Pluto, hoping that soon they will have answers to the hazy questions about the dwarf planet. Each time we gaze upon Pluto, it seems to offer something new to discover. Pluto is just one of potentially hundreds of dwarf planets in the Kuiper Belt. It's truly awe-inspiring to think about the wonders that may exist on other dwarf planets like Haumea, Makemake, or Eris, which we haven't yet had the chance to explore. Hopefully, one day in the future, we'll have the opportunity to witness their frozen beauty and unlock the secrets they hold. With the launch of the James Webb Space Telescope, we stand at the brink of a new era in space exploration. Pluto's designation as a dormant planet is quickly becoming a relic of the past as NASA unveils clear, detailed images of sophisticated geological features that have recently emerged on its surface. These stunning pictorial references mark a significant breakthrough, hinting at the dynamic nature of this distant world. It's remarkable to think that just a few gigabytes of data can unlock a world of endless possibilities for us. The wealth of information gathered by missions like New Horizons and the James Webb Space Telescope offers new glimpses into the mysteries of our universe. With each new discovery, we inch closer to understanding the complexities of celestial bodies like Pluto and uncovering the secrets they hold. Indeed, the prospect of what lies ahead in our exploration of the cosmos is both thrilling and awe-inspiring.